Hello, and thank you for visiting the channel. We are MC Automation, a specialized team dedicated to the design, implementation, and integration of communication protocols for embedded systems. Today, we will be looking at how to build the IEC 61850 library on Windows using CMake and Visual Studio, and how to run a basic example. Let's get started. First, download the source code from the customer portal associated with your MC Automation commercial license. The file needs to be downloaded and then extracted from zip format. Then, navigate to the location of the extracted library files. CMake is used to build the files, and today I'm going to be using the command prompt. If you take a look here, there is a CMake list file at the root of the project. Now, create a folder to separate the build files from the other files. Then, run CMake, since the CMake list file is one folder before our current folder, which is the build folder. As you can see, the script automatically detects the Visual Studio version installed on the computer. In my case, it is Visual Studio 2022. You can also see that the build files are being written to the build folder created. To verify, we can check that new files appear in that folder. To build the DLL file, open the generated Visual Studio project. Then, to create the IEC 61850.dll, we build the IEC 61850 shared target. This build will depend on the mode you want, debug or release. In this example, I will select release. Now, we go ahead and build it. Here we see that the build has succeeded, and the DLL has been written to the build folder, specifically under src/release. You can use this file to import the library into your own projects. Another thing worth mentioning is that the build files also include multiple examples. These examples help you understand how to use the library functions on both the server and client side. To run an example using Visual Studio, set one of the example projects, such as the server example files used here, as the startup project. Then select Debug, start debugging, or press F5, and this will then build and launch the example. This may take a few seconds because the solution also needs to be built. Now we can see that the server instance is running. In all examples, the server starts by default on port 102 and on localhost, unless arguments are passed when running. If you now run a client example, you can verify that a connection is established. As you can see, there are messages indicating connection open and connection closed, meaning the connection has been successfully established for a short period of time. This demonstration showed the basic way to build the library. However, the library also supports builds with SQLite, Embed TLS, and WinPCAP. Each of these external libraries provides additional functionality. SQLite is used for log support, Embed TLS for encryption, and WinPCAP for Goose support. If you need any of these features in your project, you must include the corresponding modules in the third-party folder of the library, then run CMake again and rebuild. As an example, let's look at how to add SQLite. There is a README file that explains how to import it. First, copy the provided link, download the files, and extract them. According to the README, you need to place specific files in the third-party folder. Before rebuilding, make sure the build folder is clean. Now run CMake again. After running CMake again, we can see a message indicating that SQLite has been found. The same process applies for adding TLS and WinPCAP libraries. After that, go back to the build folder, open the Visual Studio project, and build the IEC 61850 shared target again to generate the uploaded DLL. You will now notice that more examples are available because the library supports SQLite functionality. We have now come to the end of this tutorial. We hope you have found this information helpful, and we look forward to helping you in the next video. For more information about our company and products, or if you would like to contact us directly, please visit our website at www.mzautomation.de.